Hello guys, this is Simon from United Energy. Today I'm going to present two kinds of PV plus ESS design for commercial scenario. We are going to present the first solution is focus on the ROI, return of investment. The second one will focus not only ROI but also backup power capability. It means it can also supply the power for a few hours if the grid is off or diesel generator cannot work. So let's go to details of this solution. So here is a requirement. This is in the site and their load is very evenly. It's around 90 kilowatt per hour. And in the daily consumption is 2,300. And in the daytime it's 1,000. And in the nighttime it's 1,300. Their requirement is the first one, save the cost of electricity bill because the energy price there is $0.15 per kilowatt hour, so they are getting higher cost for the electricity, and also they want to have the backup power because if the grid is off, they don't want to start the diesel generator immediately. They want to make the system work for a few hours. After that, if the grid cannot recover, then they will start the diesel generator. So they have two kinds of requirement. And this is their detailed information site and also their single line diagram of their own facilities about how is the power supply from grid and to their equipment. And I present two kinds of design. The first one will be high ROI, saving cost merely. The second one, saving cost and also backup power for a few hours. And the configuration is like this. The first one will be 213 kilowatt peak and 175 kilowatt inverter and 241 kilowatt hour battery. And the second one will be around 300 kilowatt peak panels, 225 kilowatt inverter and 700 kilowatt hour battery. So you can see the battery size is much bigger than the solution A. Also, the difference is about the ROI. For the solution A, the payback time is around 2.8 years. And the IRR is around 33%, and the solution B will be around 4.2 years, and IRR is about 25%. And the solution B can provide backup power for 5.5 hours. It means if the grid is in the shortage, like the blackout for a few hours, then you don't have to start a diesel generator, but you will invest more battery for solution B. So we are going to use 620 watt peak PV panels. Here is N-type TOPCon, and it's bifacial panels from United Energy. And here we are using Solis on-grid inverter with 220 volt three-phase output. This is newly released product. It's on-grid. And also we have hybrid inverter from Solis, 220 volt three-phase output. Both inverters they have 10 MPPTs, which means it's very good for the rooftop scenario. You have different orientation of the panels, and so the multi-MPPT will solve this issue. And the battery, we are going to use 241 kilowatt hour battery. It's 768 watt peak volt and 314 ampere hour. And for the outdoor cabinet, we are using air cooling. The outdoor cabinet, we can put the inverter side by the outdoor cabinet, and it will be easy for you to do the cable connection and the installation. And for the solution A, as I explained before, to maximize ROI, so we don't need to put all the panels on the roof. We just put 213 or 14 kilowatt peak, and we are using this kind of metal roof type mounting system. And with this simulation, you can see you get the power output like this. It's not so, it's evenly only March, April and May it will get a higher generation. This is very good. And every year it can get 306 megawatt hour per year. And the solution A, you can see we put one on-grid inverter, one hybrid inverter, and a hybrid inverter with 241 kilowatt hour battery, and they connect together to the main bus bar. And also you can have output from the hybrid inverter to power on some essential or very important load. And also we do the zero export for the on-grid inverter and also the hybrid inverter. This is solution A. And in this, we do two cabinets. One cabinet is combined output of two inverters to connect with grid. Another one is the output. We are going to connect this with some important load in the future, but now it's vacant here. And the grid and the diesel generator will go together through the ATS, will go to the load. And then the system will just be hung on the grid, like this. And here is the consideration about the power curve. The load is evenly around 100, and you have the generation from 214 kilowatt peak panels. It's around 839 kilowatt hour per day. But also there are some days you have extra energy because the weather, the sun irradiation, they change all the time. So if you consider when you have a 13% higher irradiation, then you have this amount of the generation. And then you have the extra energy is around 205 kilowatt hour. Then you can use the battery to store the extra energy here, and it can discharge in the night in 15 kilowatt for around, I believe, 13 hours or even more hours. Then you can discharge those power in the night, and you can reduce the power supply from the grid. Then the grid will supply the rest. And this is the power curve. Okay, so say this is a single line diagram. We have 3 inverters in parallel and 3 batteries of 241 kilowatt hour, 3 inverters of 75 kilowatt. And they go together, go to this ATS cabinet. This cabinet also will go to the main load. And then this load will not directly get the power from grid, but through the whole system. And this is a diagram about how this ATS cabinet looks like. You can see the grid and the diesel generator will go together through the ATS, then we'll go to this bus bar. And then usually we can close this breaker, disconnect this breaker, put the position 2 and close this breaker, close all of this breaker. Then this will be the work mode number 1. The grid or diesel generator will go through the AC cabinet, go to the inverter, and the inverter output will go combined together, then go to the load. This is normally the work mode. But when the grid is off, then you can disconnect this breaker and put the position 2. And then this will be only PV and the ESS. Then this will be the work mode number 2. And in some days when the grid diesel generator is okay, but you have to do some maintenance for the PV plus ESS, then you can make the power from grid or diesel generator to go to the load directly. Then you put this in position 1 and close this breaker, and disconnect all this breaker. Then you can go to the mode 3. So this ATS cabinet will be very intelligent, very simple, easily for you to do the operating and maintenance. And also you can see through this inverter they work together, they can supply the power maximum 225 kilowatt. So when the grid or diesel generator, when the grid is off, then you don't have to start the diesel generator right away. You can use the whole system, the 3 inverter, to power on the load. And this is also the curve. Also I consider in the peak time it will get 30% more power than the average one. Then you have some actual energy around 560 kilowatt hour per day, and then you have 723 kilowatt hour battery. You can store those energy in the daytime and discharge in the night. Like this curve, you have a higher power generation from the PV, like the orange curve, and you have the similar load, and you have the actual energy, the green one, to charge the battery, and you can discharge the battery in the green one. And the battery cycle will be 723. In the 2 o'clock or 3 o'clock you get the full, and it will start discharge like 7 o'clock, and it will go to down. And until the morning, the minimum will be 30%, around 30%. This is also good curve. So this also is very ideal work mode for the solution B. So today, this is all my presentation about these two kind of solution. So for commercial scenario, if you want to highest ROI, then we recommend solution A. to minimize the battery and increase the PV. If you want to have some backup power for a few hours, you can choose solution B with a little bit more battery, but you have some backup power, but you will have a little bit lower ROI. So this is my presentation. If you are considering to do some PV plus ESS solution, you can contact with us, then we will analyze your need and will make a customized solution for you to reach your target. Thank you.